Our universe is a kaleidoscope of scientific mysteries.
And this month we're looking at the ideas and theories that today may sound like science fiction, but could be tomorrow's science fact.
We'll meet multiple Chris's.
Yeah, right.
We'll be discussing dark matter, and will we ever find it?
We have to find it in order to understand its implications for our universe.
We've all heard of black holes, but what about white holes?
So as a black hole gulps matter in, a white hole spews it back out somewhere else in space and time.
We'll discover whether interstellar travel is possible.
If we truly want to travel amongst the stars, then we're going to have to break some rules.
Meet the scientists trying to design a language that aliens would understand.
Will they tell us what they find beautiful?
And to help us on our strange journey, renowned cosmologist Carlos Frank takes an animated look at some of the mysteries that fascinate him.
The more we learn, the more we realize that there's a lot more that we do not know.
Welcome to the Sky at Night.
We're here at the Royal Society in London. Established in 1660, it has been at the heart of many exciting scientific discoveries.
Their members' roll reads like a veritable who's who from the world of physics. They include Isaac Newton, William Herschel, who discovered Uranus, and more recently, Stephen Hawking.
The Royal Society also has a unique collection of works and memorabilia, spanning over the 350 years of its existence, including two very special artifacts.
This book, A Discovery of a New World in the Moon, was written by John Wilkins in 1638. And in it, he discusses how to overcome the great scientific challenges for a trip to the moon. Now, what's amazing about it is that it was written 300 years before humans set foot on the moon, and well before the invention of the combustion engine, let alone the rocket.
This manuscript was written by John Mitchell in 1783. At Cambridge, he studied gravity, its effect on stars, and how they bound together to form galaxies. One of his ideas, way ahead of its time, was the hypothetical possibility of black holes. This idea lay forgotten for over 100 years, until Einstein was able to prove the case with his theories on gravity.
These ideas were considered fringe, bizarre concepts, founded in dreams, but whose reality was established many years later.
So what are today's theories, which are currently considered fanciful, but may be confirmed as reality in the future? Come with us on a journey to the multiverse of mystery to find out.
And our first mystery is the theory that there may indeed be multiple universes out there somewhere.
There is no reason to believe that our universe is unique. It is quite possible that just as our universe was created, many universes were also created. If that is the case, then we live not in a single universe, but in a vast collection of universes that physicists refer to as the multiverse. We can think of those as island universes, each with its own quirks, maybe even each with its own laws of physics. For example, there could be one of these other universes where gravity is 100 times stronger than it is in our universe. If we could somehow prove conclusively the existence of multiple universes, of the multiverse, that would be a genuine intellectual revolution, a complete change in our cosmic thinking.
Over the last few decades, we've made great strides in understanding the evolution of our grand and elegant cosmos. But big questions remain to be answered. In the beginning, we think there was a Big Bang, but that doesn't explain why we have the universe that we do. If gravity was weaker or stronger, if there was much more matter or much less matter, if chemistry worked slightly differently, then the universe would be very different and probably a less happy place for life. Now, maybe there's some fundamental theory, one we don't have yet, that explains why the Big Bang just had to produce the lovely, friendly universe that we find ourselves in. But working out the details of that fundamental theory is proving really rather difficult. But there is a way out. Where did you come from? Oh, I'm you in another universe, but slightly different. Are you real? Well, as the great philosopher Mercury once said, is this the real life or is this just fantasy? But let's put that to one side for the moment. Explaining why the universe is the way it is easy. No faffing about with the Big Bang required. All you have to do is believe in the multiverse. But I'm not sure I believe it. Creating multiple universes is an extravagant way just to get away with not understanding the Big Bang. Well, I certainly believe it. Hello, where have you come from? Well, if there are multiple universes, who's to say there's only one other universe in which a Chris exists? And there's actually evidence to support that. Some of our ideas about quantum mechanics, the science of the very small, suggest that every time an observation is made, the universe splits, creating many worlds with many possibilities. In this universe, I roll my dice, and I get a 6. But that action has created 5 other universes, one for each possibility, each with its own Chris going on in his own universe. Or maybe your dice are loaded. Anyway, I don't think this helps explain why we live in this universe, one so suitable for life. Luck, I suppose. Or maybe we just need to think bigger. Seriously, this is too many Chris's. Surely not. Well, in my theory, there are Chris's all over the place. Every time any of us make a decision, every time I sip or don't sip a martini, look left or right, look up or down, we create a new universe and a new Chris within it. My brain is too small to contain infinitely multiplying versions of myself. Well, before we melt a Chris's brain, let's get back to trying to explain why the universe is the way that it is. And there's an approach to the multiverse that can help us here. Just imagine that each universe can give birth to another universe every so often. It must be rare, so we might have to wait a long, long time for it to happen. But when it does, just imagine that this daughter universe inherits some of the properties of its parent. Now, if that's true, if that's true, then it explains why long-lived and stable universes are common. Well, it's certainly one explanation for why the universe simply had to produce me. Yeah, right. But look, this is all a theoretical flight of fancy. There's no evidence that any of you actually exist, at least in my universe. Well, the Big Bang seemed crazy, but all the evidence suggests that it really happened. Multiverses are the same way. And if I can roll enough 6s, I can prove it to you. Getting 6 after 6 after 6 is mathematically so unlikely, but in the quantum multiverse, it will always happen in at least one universe. It's just evolution in action. So how can I prove you lot right? What observation can I make? What test can I do that will show that the multiverse is real? Typical, when you ask the hard question, they disappear. So it seems that in this universe, we don't know yet. But who knows? Maybe in some other universe, somebody woke up this morning with just the breakthrough that we need. Meanwhile, in this one, it remains a mystery.
I'm not sure about multiple Chris's. Maybe one's enough, especially in this universe.
To investigate our next mystery, we're travelling to another universe, where instead of a restaurant that aims to put couples together on their first date, this one invites scientists to discuss the biggest mysteries in science.
First to arrive is cosmologist Hiranya Piris.
Hello, how fantastic to see you again.
Lovely to see you.
What I love about science is it's a way of finding out about the world that we live in, and it's full of mysteries.
So, Emma.
Joining Hiranya tonight in Scientific Conversation is physicist Emma Chapman.
I love talking to other scientists about science because they'll always have thought of a different angle of how to address a problem.
In 1933, Fritz Zwicky was studying photographs taken by Edwin Hubble of the Coma galaxy cluster. In them, he noticed that the galaxies were moving too fast to be held together by gravity alone.
Zwicky had theorized dark matter, but the problem didn't end there.
The dark side of the universe is a really big mystery. The dark matter and the dark energy make up no less than 96% of what the universe contains. The stuff that you and I, the sun, the earth, the stars, the galaxies are made of, that is just the icing on the cake. It makes up only 4% of what our universe contains. The most likely explanation for the dark matter is that it's made up of some exotic fundamental particle that came into existence just a tiny fraction of a second after our universe was formed in the Big Bang. But it is a mystery.
So back to our restaurant to discover what our scientists think about the ongoing hunt for dark matter.
I mean, the crazy thing about dark matter is that we can point to all this evidence and we can say it's definitely there, but we have no idea what it is. We just call it dark matter. It doesn't interact with light in the way that normal atoms do, like the atoms that you and I are made of, but we really just don't know.
Yes, many people think that it could be a new kind of elementary particle. We know enough about the properties of such particles in that we can say, it's probably more massive and slower moving than a neutrino. We already have observational evidence about that. But beyond that, we have not been able to narrow it down.
And it's proved very hard to find. It's not through lack of searching, is it? If you look at the average dark matter density in our solar system, you can gather that all together, all of the dark matter on Earth right now, put it all together, it would become to about the mass of a squirrel, and it could be anywhere on Earth, smeared out. How on earth are we going to find something like that?
So how are you getting on?
Really well.
Very good.
Fantastic. Could I interest you in talking more about the current experiments which are happening around the world?
Definitely.
That'd be really fun.
Brilliant.
Well, where do we start with something like that? There's so many experiments. I think the one that people had their eye on for quite a while was the Large Hadron Collider at CERN, of course. So that switched on in, 2008? People thought maybe we'll make dark matter, but nothing has turned up. So there's a little hope, but honestly, most people think at most it's just going to rule out a few of the more extreme candidates as opposed to detect it directly.
We could also try to work out if there is dark matter by signatures that you can see in the electromagnetic radiation. For example, if dark matter annihilates with itself, it could produce light. And in fact, the Fermi satellite has detected some very intriguing gamma ray bursts, which I believe you know quite a lot about.
Yeah, there was a detection in 2018 where they thought they might have seen a signature of dark matter interacting with gas in the very early universe, bringing the temperature down of what they were observing. But more evidence is coming to make people doubt that a little bit.
I personally believe that one of the best ways to look at dark matter or look for dark matter is to go underground. And so, for example, there's this huge experiments underground which is using xenon, and they're waiting and waiting for years to see if a dark matter particle will hit a xenon nucleus. And they will run for about 5 years. And in that time, they may hope to see a handful of these interactions, so real needle in haystack stuff.
Would you like to meet and chat about dark matter together again?
Absolutely, definitely. It was really fun. I think the case for dark matter is very strong. The biggest mystery is that we can't actually point to a particle and say, this is the dark matter.
So whatever it ends up being, we have to find it in order to understand its implications for our universe.
When the problem of dark matter is finally resolved, it will be a giant leap forward, not just in physics, but in the very nature of our understanding of reality itself. But there are still so many murky areas at the edge of our knowledge, even for objects we can see with our telescopes.
In 2019, this image, the first of a black hole, made headlines all around the world. But some scientists think black holes may have an opposite sibling.
I think most people have heard about black holes. Fewer may have heard about white holes. White holes are in a way the opposite of a black hole. Black holes eat everything. White holes kind of vomit everything out. Nothing can come out of a black hole. Nothing can go into a white hole. Whether white holes exist or not, it's a matter of heated debate.
Astrophysicist Becky Smethurst is an expert in black holes.
As we move into a black hole, some scientists have considered whether the forces become so extreme that a hole is pierced through the fabric of space and time, exiting in another part of the universe, or even a different universe entirely, something known as a wormhole or an Einstein-Rosen bridge. A white hole that could spew out matter across time and space is rather reminiscent of the beginning of our universe as described by the Big Bang Theory. Now, this has led some scientists to ponder whether the universe could have started inside a black hole, and that perhaps inside every black hole in the universe is another universe. Imagine you were to travel past the event horizon of a black hole. No turning back now. As you move further in, the singularity becomes your entire universe. Space stretches to infinity, as according to Einstein's theory of general relativity, the flow of time itself draws falling objects into the center of the black hole. With infinite space, you technically have room for a whole new universe. So could a white hole be the process of a black hole internally spewing out all of its contents to create a whole new universe? Imagine a family tree of universes, with each new black hole creating entire universes of their own. But there is another idea of what white holes could be. When Stephen Hawking started considering black holes from a quantum perspective, which is what's happening on an unimaginably tiny scale, he started to figure out that black holes are a little bit leaky. And as they leak this aptly named Hawking radiation, they lose mass over time and get progressively lighter. And there are scientists that are working on the cutting edge of quantum gravity that think that in the unimaginably distant future, when all the stars and galaxies in the universe have died out, black holes might go bang, effectively bouncing back all of the matter and light and information that they have swallowed over time and giving it back to the universe in one fell swoop. This bounce back could be our white hole. It's nice to think that here at the end of all things, there could be a little bit of light that comes back into the universe and maybe starts things all over again. Maybe this process has already happened time and time again.
While scientists ponder the existence of white holes and if and how they can occur, there's one thing that people do find easier to imagine, and that's the existence of extraterrestrial intelligence. In 2021, a survey found that 50% of Britons believe that aliens exist. And there are certainly lots of films and television programs that imagine what first contact with an alien civilization would be like. But how realistic are they, and how would we really talk to aliens?
Astrobiologist Douglas Varcoach has been exploring these questions in the hope one day he will speak to intelligent alien life.
Where there's life, there's language. If you imagine that we listen to Earth from the skies, we might hear one of about 7,000 languages. We would be forgiven for thinking that only humans had evolved language, but we'd be wrong. Chimpanzees gesture instructions and emotions. Whales sing to one another. Prairie dogs have warning calls so complex that experts think they describe the shape, the size, even the color of the creature that is a threat to the colony. Life's capacity for language astounds me. And it also gives me hope. Hope that life orbiting a distant star may also have a capacity for language, for communication. For me, the question isn't, does alien life exist? It's, could we communicate with them? Many years ago, in 1974, my friend, the late Frank Drake, sent a message to a distant cluster of stars using the most powerful radio telescope in the world. It's now known as the Arecibo message, our first message to aliens. Using a binary code transmitted at 2 different frequencies, he introduced counting, the DNA molecule, and a stick figure showing what humans look like, and much more. Over the years, I worked on a new message that would be even more understandable to extraterrestrials. And so, in 2015, I created METI, Messaging Extraterrestrial Intelligence. Since Frank sent that first message, advanced studies of animal communication have given us a cosmic Rosetta Stone. Using these insights, METI have created a message that teaches aliens about languages on Earth, and I hope how they can speak back to us. Our message will be a treasure trove of science, art, and human nature, with many different ways to unlock its secrets. There's one more difference between METI's message and Frank's: where they're sent to. When Frank sent his message in 1974, he targeted a globular cluster of stars called M13. It's so far away that by the time our signal gets there and we get a reply back, 50,000 years will go by. METI is targeting stars much closer to Earth, including one that's so close to home, we could receive a reply in less than 10 years, if we're lucky. So if they do get our message, will they understand it? And what will they send us back? Will they use the language of binary numbers? Will they show us what they look like? Will they tell us what they find beautiful? Will they say hello? To me, this is the great mystery. What will they pen back from their distant star? I hope to have the answer in the not too distant future.
If we were able to prove that aliens exist and were able to communicate with them, the next logical step would be to try and meet them. The problem is that space is vast, almost incomprehensible to the human brain. One way to measure it is in light years. That's the distance that light travels over the course of an Earth year. That's about 6 trillion miles. To give you an idea how big that is, our galaxy is 100,000 light years across, so it takes light 100,000 years to get from one side to the other. So with space being so vast, are we ever likely to be able to explore it physically?
Humans have always been looking to travel faster and further. And using ever more complicated technology, we've found ways to travel to places our predecessors could have only imagined. But one bit of travel has remained out of reach.
In the summer of 1950, the great Italian physicist Enrico Fermi posed a question. If the universe is so vast and our galaxy contains hundreds of billions of stars, why hasn't an alien civilization come to visit us? This simple but mysterious puzzle has since been known as the Fermi paradox. But as a space scientist and engineer, the question I want to ask is, what would it take for us to visit the aliens?
Light from Proxima Centauri, the next-door neighbour star to our Sun, takes over 4 years to reach us. And that's travelling at the speed of light. So we'd need some pretty impressive technology if we want to explore the cosmos. Interstellar technology.
So far, we've only managed to send humans as far as the moon, which feels pretty meagre on a galactic scale.
One of the major reasons for this is the space travellers were slow. Really slow. The Apollo spacecraft reached speeds of 40,000 kilometres an hour, which may sound fast, but even at top speed, it would take 100,000 years to travel to Proxima Centauri. If we want to visit other stars and the planets that surround them, we need to find a way of travelling much, much faster.
When John Wilkins wrote about travelling to the moon in the 1600s, he imagined making the journey on a large sailing ship. Well, that's not quite as crazy as it sounds, because one of our best current ideas about travelling the long distances through space is by using solar sails.
Instead of being propelled forward by wind, they use radiation pressure from light. In the future, powerful lasers could allow solar sails to travel up to 10% of the speed of light. At those speeds, we might be able to reach Proxima Centauri in around 40 years.
So solar sails could make it possible to travel to another star, but it would take nearly half a lifetime to reach even our closest stellar neighbour. If we truly want to travel amongst the stars, then we're going to have to break some rules and travel faster than the speed of light.
In 1994, a Mexican physicist called Miguel Alcubierre outlined a warp drive for faster-than-light travel, using a clever trick not to break the speed of light.
What if I want to move this ship at one edge of the table to the moon at the other end of the table? The traditional way of doing it would be to move the ship. That's how it's normally done. But there is another way. Rather than moving the ship or the moon, what if I could gather up the tablecloth that lies between them? Now, the moon and the ship are much closer together. What I've effectively done is I've scrunched up the space-time that lies between the two objects.
By contracting and expanding space-time around the warp drive in this way, we can move ourselves next to any star as fast as we like, without breaking the speed of light rule.
Of course, it's not that simple. The Alcubierre warp drive is a theoretical possibility, but the actuality of warping space-time is full of problems.
The amount of energy needed to power the drive might be a deal breaker. It was calculated to be more than all the energy that existed in the entire observable universe, which isn't ideal.
Whether interstellar travel is possible in the future still remains a mystery. But possibly with the right innovation, we may get a little bit closer to travelling amongst the stars.
Let's hope one day we really do get to travel across our universe.
Yeah, we could do a Sky at Night special from the Andromeda Galaxy, some 2.5 million light years away.
Well, it would certainly make my star guide look very different. As ever, check out our website to find out what's going on in the night sky.
And to see more of Carlos's mysteries.
Well, that's it from this universe, and that's it for this year from the Sky at Night. I can't wait to see what discoveries are made while we're off air.
So do join us for our return in 2023.
In the meanwhile, happy stargazing. Good night.
Enter a labyrinth of curiosity to find answers to questions that have mystified, perplexed and challenged. Simply listen to Inside Science, now on Sounds.